Hello. In this video, we are going to solve a CKS lab. So if you go to kodekloud.com and create your account, you get a preset of CKS challenges. It is a very good way to practice your Kubernetes skills on a proper exam-like environment. So when you start the challenges, you'll see there are 4 labs. In this video, we will do the first one. Let's click on Start the lab. So while the lab is loading, let's talk about what approach we will take to do this lab. We will do this lab as one should approach doing a question in a CKS exam. In this exam, you will have access to Kubernetes documentation. So we will make use of this. But there is also a lot of time constraint where you have to solve 16 to 17 questions in a matter of just 2 hours. So you need to know some imperative commands to quickly spin up Kubernetes resources as asked in the questions and not look into Kubernetes documentation every time. So we'll talk about what imperative commands we can use for the respective question and for what resources we actually need to look into Kubernetes documentation. We will also start the problem by creating few aliases which will help us in solving the question quickly. So let's start with the problem statement. There are 6 images listed on the diagram on the right. And using Trivy, we have to identify the one which has least number of critical vulnerabilities. And then use that image in the alpha XYZ deployment. Then we need to enable this AppArmor profile and again use it in the same deployment. We need to expose this deployment via a cluster IP service and then a network policy to ensure that this deployment, the pods deployed by this deployment are accessible only from the pod called middleware and no other pod. So let's start. Let's start by spinning up 2 consoles. And now let's start. So like I said, the first thing that we will do is to set up some aliases. You can use your aliases as per your liking. I'll tell the aliases that I use and that I have found very helpful doing these CKS labs. So let's start. First alias is alias k kubectl. So basically the very basic command to run any kubectl command, you need this alias. Now let's move over to the other aliases. In fact, to save time, I'll just copy paste and run all the aliases. So the second one is kubectl get. Then we have kubectl describe, kubectl create, kubectl run. The delete one I created slightly differently because this is a destructive command. We don't want to delete something that we don't intend to. And with delete, I give minus minus grace period equal to 1 so that things get deleted quickly and help us save time. And last but not the least, before starting the question, you can switch to the respective namespace so that you don't have to give the namespace again and again. And in this question, if you see, all of this architecture is being created in a namespace called alpha. So that's why this command says minus minus namespace equal to alpha. There you have it. We will run the same set of commands on the other console as well. We are all set to start our lab. So let's start with the first problem that we need to solve. Using Trivy, identify the image which has the least number of critical vulnerabilities. let's click on this icon. If you go down, it tells these are the permitted images. So let's see the first one. The command to run Trivy and check vulnerabilities goes like this. You are scanning an image. So as per question, we only need to check for the critical vulnerabilities. And then of course the image name. In fact, we need the count of the vulnerabilities. So it says 0. The shorter version of the command is like this. Shorter version of the output, grep -i total. It has 0. So already this image is giving 0 vulnerability. So this should be the right image to use. But let's quickly check some other images as well, just for the sake of clarity. So this one has 3 critical vulnerabilities, and the other ones, if you see, are pretty much same: 13, 1.13, 17, 16, 14. So I'll check for 17. And if 17 has vulnerabilities, then definitely the older version will also have more or equal, if not more, number of vulnerabilities. So let me just check for the 17 one. 43, too many. Huh. Okay, so we have the image to use, Nginx Alpine. So let's update the image into the deployment. So if you click on the deployment, the question says that the deployment YAML is kept at this location. So let's go there. Let's go to the other tab and let's open it in VI editor. Escape I for insert. If let's see what is set for image. If you see, there's a question mark. So we need to update that. Let's take this image name and paste it here. Okay. Let's not create the deployment yet. There are a few other things that we need to update in this YAML. So we'll create the deployment altogether. Or you can create the deployment right away and then do kubectl edit deploy command. But let's move on to the next problem first. So next we will do the AppArmor thing. So it says that uh, there is a AppArmor profile created for us at this location, and we need to load it into our deployment. And it talks about moving this profile to the default location. Like this is a default location for AppArmor profile. So let's first move this thing to the default location. CP profile into the location along with its name. All right. Now we need to basically load this profile and ensure that it is in enforce mode. So let's first see whether AppArmor is running or not. So AA status, there you go. AA status is there. So let's load the profile. The command for that is AppArmor underscore parser -q. And then let's copy it from the question, the profile name along with the path. So no error. So hopefully it is now loaded. Let us do AA status again. And this time let's do a rep on Nginx. So there you see custom Nginx is loaded. Now, whether custom Nginx is in enforce mode or not, for that, let's quickly do the AA status. And if you see, these are in enforce modes. And if you come down, custom Nginx is in enforce mode. So we are good. Now what we need to do is load this AppArmor profile into our deployment YAML. So let's again go to the deployment, open the deployment YAML. Let's open it in this tab. Now, the so to load an AppArmor profile into a deployment YAML, you need to give it as an annotation. Now the syntax for annotation is pretty long, so difficult to memorize. So now for this, we'll go to the Kubernetes documentation. Just type AppArmor and search. Restrict container access with AppArmor looks good. You calm down, you will have your annotation. There you go. This is the annotation. Let's copy it. Two important things to note, actually three important things to note when applying this annotation. First is, if you see this line, the end thing, this slash hello thing in this example is actually the name of the container. So the name of the container should go there. And the name of your AppArmor profile should start with localhost slash. Okay, so two important things. And the third important thing to note is that this annotation block goes inside the pod section of your deployment, not at the deployment's main metadata section. So coming back to my deployment YAML. So we don't apply this annotation at this metadata level. We will apply it at the pod's metadata level, which is this. So new line, let's paste the annotation. You can remove the comments if you want, escape DD to remove the entire line. Escape I, fix the syntax, and here the name is Nginx, taken from here, all right? So Nginx, localhost, and the uh, name of our AppArmor profile is custom Nginx. So let's do that. Let's remove it. Perfect. So we have done the image part, we have done the custom Nginx AppArmor thing as well. Now let's move to the other parts. So in this lab, these two were the two things which are very specific to CKS exam syllabus. The other things now are something, if you are preparing for CKS, you would already be very much comfortable with: persistent volume claim, network policy, service. So let's start with those bits. So let's click on the persistence volume. A question says a persistent volume alpha PV has already been created. Do not modify it and inspect it. We'll inspect it in a while. And then there is a PVC already created. Alpha PVC should be bound. Delete and eradicate. So looks like this is not bound. So we'll see what is missing here. So let's go to one of these tabs. Uh, kubectl get one of the aliases that I created earlier. Kubectl get persistent volumes. Let's see what it returns. Okay, alpha PV, and it has all these parameters. Let's go into the other tab and let's see what PVC returns. Okay, alpha PVC is now coming in a pending state. This is a problem, so it is not bound to this volume. So let's see what is wrong in this PVC. So let's extract this PVC in a YAML and then we'll talk about it. So I say kubectl get PVC alpha PVC paste minus O YAML to extract it into a YAML, and then I say PVC dot YAML. All right, so now if I say cat, or maybe let me open it in VI editor. So this is our PVC. You can remove the status thing as well, as we'll be fixing what's wrong here. So if you see this PVC and you compare it with the persistence volume, you will see that storage class name, storage, everything is fine, but access mode is wrong. If you see the access mode for the volume is read write many. So let's fix it in the PVC. Read write many. All right. So we'll have to first delete the PVC and recreate it again. So to delete, we'll use my del alias that I created earlier, del minus f PVC. You can delete it by giving the name or you can just give the YAML itself. I prefer doing it this way. It saves time and see that PVC is deleted. Now let's create it again. PVC created. Now let's run the get PVC command. Hopefully it should be good now. There you see. So previously it was coming pending status. Now it's bound. So PVC is also done. Now we need to mount this PVC on to our deployment. So if I click on PVC, uh, all right. Um, does it need a particular data name? Yeah. So if you click on the deployment icon, it says that data volume in code. So this is the name of the uh, volume mount is mounted at this path. All right. So let's mount this volume at this path in the deployment YAML. Again, going back to my deployment YAML. Maybe let's just open it here. What wrong did I do? Oh, okay. I do escape I. Uh, in the spec section, let me first define a volume. Let me quickly copy the name data volume and the type is persistent volume claim. Now, these are the kind of things that are available in the Kubernetes documentation, but these are the kind of things you should remember by heart and not flip to documentation on every question. Otherwise, you won't be able to complete the test in the given allocated time. So persistent volume claim, claim name, and we have our claim name ready here. Again, if you see when we do the create command and all that, we are not specifying namespace because we have already set that before starting the lab as part of when I was creating the aliases. So, okay, I've given the claim name. Now let's mount it. Sorry, that would be more volume mount and mount path. Mount path is also given in the question. So let's just quickly copy paste and give it there. Okay, so I think we are done updating our deployment. For rest of the parts, we don't really have to edit the deployment. So now would be a good time to actually create our deployment and hopefully everything goes well unless you've done some mistake. Again, I'm not specifying the namespace explicitly because it's there in the YAML and it's also set at the context level. Okay. We have made a mistake. Good to see some errors so that we can fix it. So unknown field volume mount, I think it's volume mounts. So let's go back. Oh, sorry, it's mount volumes. This time it's complaining for volume. Yeah, that is also volumes. So let's fix that. There you go. Deployment is created. Yes, ready one. So one replica is running. So all good. One replica is running, image and everything. At this point, we can also see what parts we have solved. So let's click on check. The lab has this check facility, which obviously you will not be having in the actual exam, but let's leverage this check button and see what parts we have solved so far. There you go. So you see the volume thing, the image thing, AppArmor thing is all in green. So we have implemented these many things. Now let's talk about the two remaining bits, the service and the network policy. So let's go to service. We need to expose it with a service called this and port 80 type cluster IP. Again, now let's use a imperative command. No need to create the entire service YAML to save time. The command is kubectl expose deploy slash the name of the deployment, which is alpha XYZ. All right. Expose minus minus name, the name of the service, and the name of the service would be alpha SVC. Minus minus port equal to 80. No need to give the target port, as by default target port, if you don't specify, it will take the value of the port, which is same in our case. So you can also quickly check the service. Kubectl get SVC, alpha SVC, paste minus O YAML. You see everything is in order. 80, target port 80, type cluster IP, namespace, alpha, name is alpha SVC. All good. Now coming to the last part of the problem, the network policy. Network policy says the name it should be this restrict inbound in the alpha namespace. Policy type is ingress and it should only allow ingress from a pod called middleware and nothing else. And the label is also specified. The middleware's label is specified. Okay. So first of all, we need to apply this ingress. Let's first apply a default policy where we deny all ingress and then we only allow from this. Now, network policy is something you should quickly refer the documentation to. Let's first talk about deny. All right. Deny all ingress. Example is given to us. Let's quickly copy this one and okay, bye. Let's paste it. So we are denying all kind of ingress. So that's fine. Let's create this network policy. Cool. Now let's create an allow.yaml. Escape I. Now you can take the syntax from here. Maybe let's take this, and we don't need the egress part. So we'll take this and then clean this entire thing. All right, let's remove this egress. Namespace, change it to alpha. Network policy name is given in the question. Let me first remove this one. Okay, the name of the policy is restrict inbound. Oh, what am I doing? Wrong terminal, sorry. Okay, so restrict inbound name is given. Now the pod selector label, we can actually take it from our deployment as well. Maybe let's quickly look at our deployment YAML. So the label here, as you can see, is app colon alpha XYZ. So let's take this label. And in the from block, we only need the pod selector. So let's remove these extra lines. Escape colon DD. And then, yeah, we have this pod selector. Let's just change the label, matching the label of the from side. And in the question that is already provided to us, that the middleware pod should have this label app colon middleware. So let's take it. Let's change the equal to a colon. All right. Port should be 80. Yeah, that's the service that we exposed, and that's what the pod is also listening to. So let's change it to 80. All right. Anything else missing? Looks all good. Cool. Network policy is created. So with this, hopefully all the parts of the problem are solved. Let's test. To check the network policy, what you can also do is you can log into this external port. You can exec into this pod and then try to do a NS lookup kind of a command into this service, and that should fail. Only middleware pod should fail. But we have this check button provided, so we'll let the lab give us the feedback. There you go. The lab is completed. It's all done. So key takeaways, we ran the trivy command to find the image with least number of vulnerabilities. We loaded the AppArmor profile. Then we found the issue with the persistent volume claim, updated all these things in the deployment YAML, created the deployment, and then uh, we exposed it via service and created a network policy on top of it. We also saw where to use imperative commands and where to look at Kubernetes documentation, and we also looked at some of very useful aliases. So that's all for this video. I'll see you with the next lab. Thank you. Bye.